if we look at explicit formulas for recurrence relations, we're going to need to look at more sums. And often when you're doing these recurrence relations, you're going to see things like maybe you're going to have like 1 plus 2 plus 3 plus all the way up to n. That's going to be equal to n plus 1 over 2. So whenever you're adding up consecutive numbers up to n, that whole sum will be that. On the other hand, if you're summing the squares, those will add up to that. So if you're summing cubes, and you're summing up to n, that's going to be n times n plus 1 divided by 2 squared. So keep those equations handy. In fact, we can use one of them on this next example. So once again, we're given a recurrence relation, and we want to find the explicit formula. And just as before, we'll find the pattern. So just like before, A2 is A1 plus K cubed. And then A1 was 1, put that in. A3 is going to be A2 plus 3 cubed. And then for A2, we have this. And then we'll add this one on. A4 is A3 plus 4 cubed, which is equal to A3 was this. Oop, I messed that up. This is 1 plus 2 cubed plus 3 cubed. That was a 3 and plus 4 cubed. And of course, this can be written as 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed. And you can see the general pattern. This is 4, and this happens to go up to 4. So the general pattern is AN 1 cubed, 2 cubed, 3 cubed, up to N cubed. And of course, this was one of the equations we just looked at. It was this sum right here, which leads to this. And we have that. So this is our explicit formula. And we could check it real quickly we have a 4 here. A 4 sums up to 1 plus 8 plus 27 plus 64, which is 100. So A4 should be 100. So let's put 4 in here. So we have 4 times 5, which is 20. Divide 20 by 2, that's 10. And we square it, we get 100.